this next class period, we're going to try to take precise measurements. And the more precise measurements we're going to take, the better our results. So what is it that we're going to measure? Well, we're going to measure things in nature, more specifically things on our body, but we'll get to that later. I wanted to introduce you to phi. Phi, which has a Greek letter with 0 with a line going through the middle of it, is equal to 1.618. Now, when I say that, there are other digits that follow, but I'm not going to write those down. It's an infinite number of digits. I could write it forever and ever and ever and ever and ever and never finish writing it down because it's known as an irrational number. Other irrational numbers are numbers such as pi, okay, which is 3.1415, but it never ends. Phi falls into the same category. Now we see phi in many different shapes and forms throughout nature, from the very small of a DNA molecule to the very large in the form of a galaxy, and anything in between. Here's weather patterns, here's a flower, here's a shell, and then here's some more plants. So let's look at our next slide and talk about the nautilus shell and how phi applies to a nautilus shell. Okay, so to understand the concept of phi, we are going to look at a nautilus shell. And in our nautilus shell, we're going to start right here, because this is the tangent of where this circle comes. And then you see it spirals around, and then the other end of this tangent ends up over in this side right here. So this is going to be one of our lengths that we're going to look at. Then we look at another length. Let me change the color so we can look at it a little better. And here is, right here, is our next length. And you see here that's tangent to this curve right here. And notice that these make our ratio. Now, we're going to first look at this length. Let me change my color here. So from here to here, I'll just keep this in red. And here we're going to call this 1. And then if we go all the way across from here to here, that if this is 1, then this length right here should be approximately 1.6. And I'll say 1.62, even though it's 1.618, just to round things up. And we could even take that further, and if we notice that from here to here, you get the same ratio, from here to here, you'd get the same ratio, and so on and so forth, and all the way until we get down to as far as you can get. All right, here we have our different pictures, and my little measuring device, it would be nice if it was transparent, but it's not, so we're going to make the most of it we can use. So you can see here that A is the length from this first curve to the second curve, and that's what we called 1 in the previous slide. And then from A to B, that would be our 1.61 or 1.62 ratio. So A plus B gives you gives you that ratio. Now, if I take this to different sides, let me see if I can shrink this down a little bit to make it fit this. And you notice that when I get it down to the right length, again, you can see the length from here to here and to here is A plus B, and then from here to here is our length of B. So this is 1, and then this, if this is 1 from here to here, then this would be 1.6, roughly. And that works for all of these different pictures if you know what you're looking for. Here's a picture of the Parthenon. The Greeks noticed this golden ratio in nature and decided to utilize it in their architecture. So if you notice, you have the length of the Parthenon that goes across like this. And then if you were to take that and you were to divide that length by the golden ratio, and so you can see that if I bring down my phi measuring device, and I've got this end lined up roughly there, and this end lined up there, and then that makes this dot line up with this line right here. Well, when I take this and turn it, then if I can keep the ratio the same, which is not easy, you notice that this line lines up here and this line lines up here. So what does that mean? Well, that means that this is a square. Okay, so you have the length of this going across, and then you divide the length by phi, and then you extend that line going up to make a square, and there's the height of the original Parthenon. Now, as these buildings get older, they start to deteriorate, so they drew in where the height of the Parthenon would have been back when it was built. And we take this and we keep on dividing it. Now, this is the new section over here, and so then we take this new section and move our phi measuring device, and notice that, look at that, it lines up here, it lines up here, and most importantly, it lines up right here. So the ratio, and we can continue that all the way around, and it's just like the Nautilus shell. Now, interesting thing, and I won't continue going down because I think you guys get the idea, but I will point out that certain features line up. This line right here lines up with one of the ratios. This section right here, notice it lines up with this, and then this bottom section down here lines up with this little section right here. So the whole thing is based on the golden ratio. I don't know if it was by accident or by design. I would like to think it was by design, but it could have been by accident. But that's how it was used in architecture. Okay, here's the measurement that you're actually going to take in the classroom tomorrow. This lab is going to be divided into two parts. And you're going to get several people, at least 5 people, to measure the height of the person from head down to their toes or their heels without shoes. All right, so you want to make sure that you get barefoot. And if you notice that this is divided, here's our 1. From the belly button to the head is 1, and from the belly button to the floor is 1.6. Now what you guys are actually going to measure is the total height and compare that to the belly button height. And what you should notice is that the two numbers are going to be reversed. So let me write that down for you. Make sure I have a good color there. So this, from here to here, would be your 1.618 ratio. And let me change colors really quickly. And then from here to here, that would be your 1. And then that ratio should hold up whenever you graph it. So when you're graphing, this ratio needs to go into your y-axis. Okay, so this is going to go to the y-axis because we're gonna want to have our larger number on the y-axis, and so that leaves the other number where? Of course, on the x-axis. So make sure that when you set up your data table, you set it up from the height for the y-axis depends on the height from the belly button, height of the belly button, as your x-axis. So this is your independent variable from here to here, independent, and this is your dependent variable, the entire height. Here is an example of what you're going to be measuring, okay? Here's our person, our sample person, which is tomorrow going to be you and 4 or 5 of your buddies. And you're going to measure from the height to the heels. Now make sure you stand straight and you are not wearing shoes. You're in your bare feet. And those values are going to go here. So the first person would put their data right here, second person right here, third person right here, fourth person right here, and fifth person, and so on and so forth. The belly button height, now again, you're going to make sure that you are going from the heels and you stand up straight. If you slouch over, it's going to change the belly button height. So stand as straight as you possibly can when making that measurement, and it's going to go from here up to here, and those values are going to go right here, and there's for your first person, your second person, your third person, and so on and so forth. Now it goes without saying that make sure that this person and this person, each one of the datas line up, that you don't get confused as to who goes where. Deviation. Now once you have all of your data, what you're going to need to do is you're going to find your average. So you take all of the values, you take first, second, third, fourth, fifth, maybe sixth and seventh, but we'll just say we have 5 of them so far. We have 5 values, and you're going to add them up and divide by 5 to get your average. Now what are you going to do with that average? Well, you're going to find whatever you have for your height. The first person, you're going to subtract. You're going to subtract the average. So this is going to be minus the average. And the same thing for the other side. For your belly button height, you're going to find your average of belly button heights, and once you get your average, you're going to go back up, and each one of these you're going to subtract the average from all of your values. If you have 5, you're going to go all down the list and sequentially subtract the average, and that's going to give you your deviation. Now once you get your average I'll get to the fractional deviation later, but basically it is taking each one of these values right here and then dividing it by the average. But I'll tell you more about that in the next slide. Now also be aware that you're going to be graphing. So when you're graphing, you notice that these are the smaller values. We're going to put the smaller values on our x-axis. Okay, so make sure that you're aware that these are for your x-axis. And so that leaves this one for, of course, you all know, let me change colors. This one is going to be for your y-axis. All right, and almost every lab we do, we need to make sure that you are collecting data, and you have the correct, and you know which is going to be your independent variable, which is going to be your x-axis, and your dependent variable, which is going to be your y-axis, and you get some type of a line. Here we have a sample data. Now this is just a sample. Your numbers are going to be different when you measure them in the lab time next time. But I wanted to point out, here's our height measurements right here. And we have 1, 2, 3, 4, 5 different heights. And we have the belly button heights, 1, 2, 3, 4, 5, and these numbers correspond to each other. This is the same person. This should be the same person. This should be the same person. That should go without saying. Then we also are taking these 5 data points, these 5 pieces of data, and we're adding them up and dividing by 5 because that's how many numbers we have. And that gives us 177.2. We're going to take 177.2 and subtract it sequentially going down the list. Now, if you notice, 165 minus 177.2 is negative 12.2. But we don't write negative 12.2, we write positive 12.2 because we just want to find what the difference is and how far off our numbers are from the average. So then we are going to do that for our heights. And notice that we go down and we write our deviation for our heights. Then we go to our belly button, do the same thing. We take these numbers, find the average, and the average of all 5 of these gives you 108. And notice 104 minus 108 is negative 4, but we don't write negative 4, we write positive 4. And then we go on down. Now, once we've got our deviation, we're going to find our average deviation. Our average deviation is the same thing. You take the numbers, you add them up, and divide by however many numbers you have. You do that for your height deviation and for your belly button height deviation. And we get a deviation for the height of 9.36, a deviation for the belly button of 4.6. Now what do we do with that? We get our fractional deviation. Well, we're going to take this 4.8 and we're going to divide it by 108 to get 0.044444444. But this case we only wrote down 5 digits. I would suggest not writing quite so many, but maybe three digits after the decimal point, or 3 significant digits is perfectly fine. The same thing here. We took this average 9.36 divided by the average height, and that gives us our fractional deviation for height too. Notice these are two very small numbers, which is good. We want the smaller the fractional deviation, the better our data. And then we have this other number right here, which is our fractional deviation. If we took this number, we added it to this number, that'll give us our fractional deviation, which is down here. Also, we're going to take, if we took our average height and divided it by our average belly button height, that's going to give us our calculated phi. Our calculated phi. So that's the average height divided by the average belly button height, and that's going to give us this number right here, which is what I'm going to call your calculated phi. And I'm going to rename that though. And let me see if I can rewrite this a little bit to make it, because I'm going to use this as an equation. So I'm going to call all of this together phi, comma, or brackets C, and the C stands for the calculated value. Now, we'll also have our phi. Let me change the color here. The known phi. And if you remember, the known phi, which is what I'm going to call K stands for known, and that's the equals to 1.618. So I've got my two values here. I've got the 1.68, which is my known phi, and I've got my calculated phi, which is this 1.64. Notice these two numbers are very similar, but they're a little bit different, and we want to know how far off are they different. So what I'm going to end up doing then is I'm going to take my phi calculated. Okay, so my phi calculated, and I'm going to subtract from that my phi known, and that then take the whole thing and divide it by my phi known again, phi known, and take my absolute value, because remember, percentages shouldn't have a negative number, and multiply that by 100, and this whole thing right here, see if I can capture it all, is the calculation necessary to get this number right here. Now, that's this part. Now the next part we're going to look at is how to make a graph, because this is one relative error. We also want to look at how to find the slope, because the slope is also going to give us a value for phi. Okay, here's how we're going to make our graph. Again, you want to make sure that you line up an appropriate x-axis, and notice that our smallest value is 98 and our largest value is 114. Now, because we said our belly button height should be our x-axis, notice that our smallest value is 100, which is right here. So there's our 100, and we don't have to start at 0. Remember that. because all we're looking for, ultimately what we're looking for, is a slope. So the more graph that you can use to get that slope, the better. So here's 104. 104 corresponds to a height of 165. So we look at this, 104 going up, 165 going going out is 104, going up is 165. And notice also we're starting at 160. We're not starting at 0. So don't feel compelled that you must start at 0. You can start at whatever number you want to, and you want to make sure you use as much of your graph paper as possible. So this value, this dot corresponds to this data. This is 113 right here, which corresponds to here. This is 109, which corresponds to this data right here. This is 114, which corresponds to this. And so you're going to make your dot right here. Now, notice that this line is not connecting the dots. It is a straight, the best representative of the straight line. Now I used Excel to give me the best trend line, and I also told Excel to help me calculate what the slope is. Now, to find your slope if you're not using Excel, Excel makes things nice and easy, but if you're not using Excel, that's fine. You just take a couple of data points, like for example, I could take this point right here, and I could take this point right here. Now, if you remember, the slope is equal to the rise divided by the run. Now, the rise corresponds to your change in y, and so your change in y is going to go from here to here. So this is going to be your delta y. And your run is going to correspond to the values for your x-axis. So your run goes from here all the way to here. Now notice I'm not picking, the 2 points I'm picking are on the line. They're not any of these little data points right here, because once I get my trend line, I just want to find the slope of that trend line. And this is corresponding to delta x. So we write delta x right here, and hopefully you guys can find x1, y1, x2, y2, and plug them in appropriately on the slope. If you need help with that, I will help you with that when you get to that part tomorrow. But that's the idea that I want to have. And then that will give you, ultimately, your slope. In this case, it's 1.79, which is pretty far off from what our value that we want, which is 1.618. But that's fine. This is an exercise in taking accurate measurements. If I saw something like that, I would say probably these values were not taken with good precision, or maybe somebody that there might be a couple people that aren't exactly match the phi ratio. But more than likely it's due to sloppy measurements, which is what you want to avoid. In part 2 of this lab, you're going to measure different parts of your body and understand the different ratios. So this one happens to be the first one. So this is our first measurement, and I'll call that number 1. And it describes it as the length of the third digit of the index finger versus the length of the second digit. So this is this portion right here would be the third digit. So this is the first digit, this is the second digit, and this is the third digit. So you're going to measure this digit and measure this length from here to here, and that would be your first measurement. Now the second measurement you're going to make will be from, again, the tip of the finger, but this time you go to this knuckle right here. So you're going to measure that to that, and that's going to be your second measurement. The second measurement we're going to take is going to involve the middle finger. And hopefully, as teenagers, you all know how to use your middle finger, but that's not how we're going to use it today. We're going to use it in relationship to phi, the golden ratio, again. And so how are we going to use it? Well, we're going to measure the entire length of the finger. So it's going to be from the tip to the knuckle. So this length from here to here is going to be your first measurement. Your second measurement is going to be involved from the tip of the finger to the middle. The second knuckle. Well, the second knuckle is actually right here. So you're going to measure from here to here, and that length will be your second length. And so you just make sure that you put the longest one in the right column and the shortest one in the correct column also. The third measurement you're going to take is going to be involved with the wrist, or from the elbow to the wrist. So from here to here is going to be your first measurement. So let me draw a line right here for the elbow, and then I'll draw another line right here for the wrist, and this length from here to here is going to be your first measurement. Your second measurement is going to be involved from the elbow all the way to the tips of the finger, which the tips of the finger is right here. So if we were to draw that out, we'd start at the same place and go all the way to the tip of the finger, which is right about there. And there would be your second. So the red would be your longest measurement, and the blue would be your shortest measurement. The fourth measurement you're going to take involves the length of your entire arm from your shoulder from right up here to the tips of your finger, which is right down there. So this is going to be your first measurement, which will be, in this case, your longest measurement. And the second one is going to be involved from your elbow. So you want to go from your elbow, which starts right here, and goes all the way down to the tips of your finger. So the first measurement, and the blue is your longer one, and the red would be your shorter measurement. The last measurement we're going to take, which is our measurement 5 on our bodies, is going to be involved with the measurement you've already taken, which is from the top of the head to the bottom of the feet, and that's going to be your first measurement. And then your second measurement, which you've already done, and you probably already know where I'm going with this, is from the belly button down to the heels again. And the shorter one would be my red line, and the longer one would be my blue line. And then once you've got all 5 of these measurements, you're going to graph them and see if the slope, how close the slope is of your graph to 1.618.